Alright, hi, it's Megan, and this is my solution to the dog matrix problem. Okay, so to start off, to find a matrix that gives this transformation of the dog, I started picking vectors from the original dog, which, let's see, like you could see this 0, 2 vector, and I visualized where that would change to, and that's this 0, -4 vector. As after the different reflections and transformations, that's going to be the vector that gives. So I went ahead and plugged that in for an arbitrary matrix ABCD, and did the arithmetic to solve for as many variables as I could. So I was able to solve for B and D, and then I did the same thing again, but I chose a different vector this time. So that 3, 0 vector, which is right here. And again, after the transformations, I could kind of see that it was gonna switch up to this -6. Yeah, -6, 6 vector right here. So same process, except I plugged in the B and D I found in the previous step and solved for A and C. And you can see on the right side of my screen, I switched the sliders over to make it so it equals that transformation. And you can see that the A is in charge of like the horizontal flips, the horizontal stretch, and flipping over X. You could see because it's of that negative value, and it's not that 1, the value of 1 that it started with. So if we move the A around, you could kind of see that happening. You can see it flip over the, did I say that wrong? Flip over the y-axis, not the x-axis. But you can see how that changes. So I'll go ahead and put it back to -2. And then D was in affected the vertical stretch. Oh, that's not what I meant to move. B 0. Did not mean to move that. D is what's stretching this thing up vertically. So I'll go ahead and move it back to where it was before. And then C shears the dog vertically and flips it over Y, so you can see. Flips it over X, because it mixed those two up. Mixed those two up. But there we go. Go ahead and put C back to 2. So that's how the individual components affect the dog transformation. And then I went ahead and looked for 3 matrices would multiply together in the correct order, give the matrix that I just found. So we can see this was just kind of the process that I did to get my answer. I knew I needed these 2 reflections to happen, so I just used the basic like reflection matrices and multiplied them together. And then I got this product right here, which is similar to where I want the negatives in the A matrix. So then I multiplied it by this arbitrary ABCD just to kind of see what I needed those values of this final B matrix to be in order to get the matrix that I started with. So then I solved for that, and I realized I needed A to be 2, B to be 0, C to be -2, D to be 2. Then I checked it again and got that for multiplying them in the order B, C, D, these three matrices would give the original matrix that I had. And you can see right here the different matrices each affect the dog in a specific way. This D matrix is the reflection over X. The C matrix is the reflection over Y. And then B is kind of the shear factors combined into one. And that